Welcome to the first important formula that you're going to learn in this entire chapter. And I'm not going to give you the formula straight away. I'm going to explain to you the concept behind it and eventually how that leads to the formula being formed, right? Because it's very important in this chapter that you actually understand what you're learning rather than just blindly memorize the formulas. Okay, so let's just take this as an example over here. Let's just say I have five distinct objects. Okay, I have five distinct objects. So let's say I have A followed by B, followed by C, followed by D, followed by E. Right? We can all agree that they are all distinct. So the question is, how many different ways can I arrange them? Right? How many different ways can I arrange them? So the thing is, you have five different objects, and now you need to arrange them in the five different slots, right? So you have 1, 2, 3, 4, 5. So you can see that, even when I write it this way, right, this itself is, this whole thing over here is already one possible permutation. And the reason why we call this a permutation is because when we are talking about in the context of arranging, right, the order matters. So we already have one possible permutation, but how many permutations are there exactly? So you can see that in total, I have five different slots, right? 1, 2, 3, 4, 5. I have five slots for five different alphabets. And the thing is that they cannot repeat, right? Obviously, because if let's say you put A here, right, then you strike out the A over here, you wouldn't be able to put another A over here because you don't have another A, right? So they are all distinct, right? And of course, there is a lot of different scenarios that we'll cover later on in the subsequent videos and more formulas to come. But this is the the constraint of the question, right? They're all distinct. So let's just start off with the first slot over here, right? In the first slot over here, so first slot, third, fourth, fifth, how many different alphabets can I choose from? I have five different alphabets that I can choose from, right? And let's say I chose the first one. It doesn't matter what it is, but when I choose one, how many are there left? There will be four left, right? And when there's four left, in the second one over here, I can fit in four different possible objects, four different possible alphabets, right? And then let's say I fill in the second one already, I have already used up two different alphabets, right? So by the time I hit the third slot, right, how many different alphabets are there left for me to choose from? By the time I hit the third slot, I will left with three different possible alphabets that I could choose from, right? And then of course, this process repeats itself all the way until the end. And by the time I hit the last slot, right, you realize that at the front, all the way until where we are now, we already used up four different alphabets. And therefore, in the last slot over here, there's only one alphabet left. So you can see that the total number of ways, total number of permutations, or you can think of it as the total number of ways where the order matters, is just 5 times 4 times 3 times 2 times 1, right? Because we got 5 options at the start, and then followed by 4, followed by 3, followed by 2, followed by 1, right? And this, in other words, is also known as your 5 factorial, right? Because you know that the concept of factorial is that, let's say I have n factorial. N factorial is basically n times n minus 1 times n minus 2 all the way until you reach 1, right? That's why for examples like 3 factorial is just 3 times 2 times 1, right? That's why you get 6, right? Then you have 4 factorial is just 4 times 3 times 2 times 1, right? And then you go all the way, right? So this, in other words, is your 5 factorial. So therefore, right, what is the formula to actually compute this, right? When you have n distinct objects, how many ways are there to arrange the n distinct objects? And the formula is actually what I wrote over here, right? So the formula behind this is just n factorial. So I'm just going to write here, right? The formula is for n distinct objects, there are n factorial ways to arrange them, right, where the order matters. Okay, and at the start, this is not going to seem like common sense to you, right? But just run through the example that I went through earlier again and again and again. You'll realize that, yeah, after a while, it does make sense. Okay, so the best way to make this click for you would be to practice, right? So over here, I have an example question. Pause the video now to attempt this question. Okay, and once you're done, return back to this video. And if not, I'm going to assume that you've done it already. And now we're going to tackle this question here. So I have 5 men, 5 women. How many different ways can they pair up with each other? So the way that I would think about this, right, is that, I know the constraint of the question. So the constraint is very important, right? I know that a man must be paired with a woman, right? Definitely. And I have 5 men at the start, right? So I'm going to imagine the 5 men. Okay, so imagine the dating service. Okay, so whenever you do matchmaking, right, you have the 5 men standing over here, right? 5 men. So this is man 1, man 2, man 3, man 4, man 5, right? You imagine all of them standing in a row. Now I got 5 women now. So the 5 women are all here. So I have 5 women. So 5 women or women. So when we go down the line for the men, right? When it comes to the first man over here, how many different women could be paired with him? Right? The first man over here has 5 different women or women that could be paired with him. Right? It could be, we know that definitely one of them must pair with him. Right? And then when it comes to the second one over here, how many different women can pair with him? 4, because the first one has already been snatched by the first man. So by the time we go to the third man, right, how many women can be paired with him? Only 3 more, right? Because the first 2 have already been taken, right? And this is the reality of life. It's like let's say you like this girl, right? But then she's already been taken by your friend. Then you're only left with 3 girls. But that's just the reality, right? You can't go back to go and take her back because she's already been taken by your friend, right? And then you cannot break the bro code. So you just gotta like live with what you have, right? The 3 women. And then after the third man, if you're the 4th man, you are left with 2 women, right? And then last but not least, if you're the 5th man, you are left with the one and only, the fated one. So in total, how many different pairings are there, right? So there will be a total of 5 times 4 times 3 times 2 times 1 different pairings. And we know that when we take, the total number of pairings, right? We know that the first man can be paired with 5 different possible women, right? So from the first man, there are already 5 different possible pairings. Now, when it goes to the second man, he can be paired with 4 different women, which means that there is already 4 different pairings, 4 different possible pairings. Right? So if I could just draw this out for you to visualize, right? Let's say this is man 1, right? Man 1 over here, 1, 2, 3, 4, 5, right? You got 5 different pairings, right? 1, 2, 3, 4, 5. Okay, maybe I should just extend this a little bit more, right? The man 1 over here, right? Then when it comes to man 2, man 2 will have 1, 2, 3, 4 different pairings, right? Depending on which women the guy choose at the start, right? Man 1 choose at the start. Man 2 will have 4 different pairings. You can imagine it like 1, 2, 3, 4, right? Depending on which women the guy chooses, right? If man 1 chooses, say, this woman first, then after that, then man 2 will carry on this branch, right? But let's say when man 1 chooses this woman first, then you will go down this branch. But at the end of the day, we are just concerned with how many branches are there in total. So therefore, this is just 5 different branches from the first one, followed by 4 different branches from the second one, then the third one, then the fourth one, then the 5th one, right? This, in other words, is your factorial. So this is your 5 factorial. And therefore, when you key 5 factorial into your calculator, or you just manually key this, you get a value of 120 different pairings, right? And that's the answer to this question over here. Let me know if this made sense to you, and if you've got any other questions, just leave it in the comments below. If not, I hope this was helpful, and in the next video, we'll be moving on to the next concept under this chapter. I'll see you then.